Welcome viewers. Today we are going to look at the topic three-dimensional geometry. Three-dimensional geometry. Now this topic relates to the common solids learned in Form 1. Now there are some geometrical properties of solids that you need to understand. A figure having length only is said to be in one dimension, and it's represented by a line. Then a figure having area, that means this figure has the length and the width, then the figure is said to be in two-dimensional geometry. Figure having volume, that means the figure has the length, width and the height, okay, is said to be in three dimensions. Okay, we said a figure having volume is said to be in three dimensions. For example, in this figure it has the length, it has the width, which is BC, and then it has the height, which is CG. So a figure having length, width and height is said to be in three dimensions. Now solids can be considered in terms of its vertices. Okay, vertice we mean the point. For example, point A is called a vertex, point B is called a vertex, C is called a vertex, F, G, H. So this point is what you call a vertex. Or edges. What is edges? Edges are the line. For example, we have AB is called an edge, BC is an edge, CG is an edge, BF is an edge. So an edge is a line. Then finally we also have faces or planes. For example, we have this face ABFE, that one is a face. BCGF, that one is also a face, or it's called plane. So a solid can be considered in terms of its vertices, the points, edges, that is the lines, and then the faces or planes, which is now ABF, G. Now what's the same figure? If we can use the same figure, then we can get the vertice vertices will be equal to, we said vertices are the points, so we have 1 2 3 4 5 6 7 8. So the number of vertices this figure has is 8. Okay, what about the number of edges? Okay, edges we said is the line. We have a line AB, that is 1, BC, that is 2, CD 3, AD, that is 4. Then we have AE 5, BF 6, CG 7, DH 8. Then we have EF 9, FG 10, GH 11, HE 12. So the number of lines is 12. Then finally we have the faces. The number of faces will be equal to, for example, we have ABFE, that's one face, and the opposite face, that is CGHD, those are 2. Then we have BCGF, that is and the opposite, that is ADHE, there we have 4. And then we have the base and the top. Okay, those are 5 and 6. So the number of faces we have are 6. So that is how you can find the edges, the face and the vertices of a given solids. Formula you can use to find the number of vertices, the number of edges and the number of faces. And the formula is faces plus the vertices will be equals to edges plus 2. Edges plus 2. And this formula is called Euler's formula. Euler's formula. Let's assume we don't have the number of faces. Okay, they don't have the number of what? The number of faces. Now let us use this formula to find the number of faces if you are given the vertices and the edge. Okay, now faces we don't have f, plus the number of vertices are 8, should be equal to edges, which is 12 plus 2. The number of faces we don't have f plus 8 should be equal to 12 plus 2, that will be 14. So comes together, we take 8 on the other side, therefore f should be equal to 14 minus 8, and the number of faces will be what? Will be 6. So the number of faces will be 6. So that's how you can use the formula to either find the number of faces, the number of edges, and the number of vertices a figure has. Thank you very much and welcome.